Today we will show you the top 10 futuristic mind-controlled prostheses. Advanced prosthetic limbs that can be operated directly by the user's thoughts are known as futuristic mind-controlled prosthetics. By interpreting neural signals from the user's brain and translating them into motions of the prosthetic limb, they make use of brain-computer interface technology. Comparing this to conventional prosthetics, more intuitive and natural control is possible. These prosthetics have the potential to enhance amputees and people with disabilities' quality of life. Give a thumbs up and hit the subscribe button. Let's get into it. Number 10. BrainGate Systems. The BrainGate system represents the height of innovation and provides a game-changing option for those suffering from severe paralysis. The BrainGate system, created by a cooperative group of researchers at Brown University, makes use of state-of-the-art neural interface technology to enable direct brain-to-external device connection. A tiny sensor array made up of microelectrodes that is surgically inserted into the user's brain's motor cortex is the central component of this device. These microelectrodes have the ability to capture brain activity, more precisely the electrical impulse patterns produced by the neurons in charge of motor control. Sophisticated algorithms can interpret these neurological impulses and convert the user's intended movements into commands for prosthetic devices, like computer cursors or robotic arms. It's amazing how this works in real time, giving you smooth, natural control over external equipment with just your mind. The BrainGate system's adaptability and versatility are among its main advantages. To ensure optimum performance and responsiveness, the neural interface can be adjusted and tailored to each user's own neural architecture. Number 9. Luke Arm. The Luke Arm is a living example of the creativity and inventiveness propelling the prosthetics industry. It was inspired by the iconic Bionic limb from the Star Wars film series. This cutting-edge prosthetic arm, created by DICA Research and Development Corp., provides an unprecedented degree of capability and natural mobility in the field of upper limb prosthetics. The Luke Arm's advanced control system, which makes use of the electromyography (EMG) impulses produced by the user's residual muscles, lies at the heart of its construction. The Luke Arm can identify even the smallest muscle contractions and convert them into precise movements of the prosthetic hand and arm by carefully positioning sensors on the surface of the user's residual limb. The Luke Arm is unique because of its amazing dexterity and range of motion, which nearly resemble those of a normal human arm. Users may execute a wide range of tasks with accuracy and grace thanks to the several degrees of freedom and articulation. These tasks range from easily manipulating sensitive instruments to gripping things of various sizes and forms. In addition, the Luke Arm has user-friendly control interfaces that let users effortlessly transition between various grip patterns and functionality. These interfaces include buttons and switches integrated into the prosthetic socket. Improved overall user experience and increased independence in daily tasks are made possible by this user-friendly design. All things considered, the Luke Arm is a major breakthrough in upper limb prosthetics, providing users with a degree of use, adaptability, and natural mobility that was previously unthinkable. Through the integration of state-of-the-art technology and user-centric design concepts, the Luke Arm is enabling people who have lost limbs to regain their freedom and fully experience life. Number 8. Modular Prosthetic Limb. In the field of neuroprosthetics, the Johns Hopkins University Applied Physics Laboratory's modular prosthetic limb represents a revolutionary development. The MPL is a flexible solution that can be used to improve quality of life and restore independence for people who have lost or are impaired in their upper limbs. It is intended to give these folks previously unheard of degrees of functionality and control. The modular architecture of the MPL is at the core of its design, enabling customization and integration of cutting-edge sensors and algorithms suited to each user's unique requirements. With the use of an advanced neural interface system included into the MPL, users can effortlessly and naturally control their prosthetic limb by decoding neural signals from their brain. The MPL's capacity to give users sensory feedback enhances their experience of embodiment and facilitates better interaction with their surroundings. This is one of its primary features. Through the incorporation of tactile sensors and haptic feedback systems into the prosthetic hand, the MPL can provide the user with information on the texture, shape, and temperature of things, hence enabling more precise and intuitive item manipulation. Additionally, as new technologies develop, The MPL's modular design makes it simple to integrate upgrades and new functions. This guarantees that users won't require major hardware replacements or adjustments in order to take advantage of continuous improvements in neuroprosthetic technology. All things considered, the modular prosthetic limb is a paradigm change in upper limb prostheses, providing users with a degree of sensory feedback, adaptability, and dexterity that almost perfectly mimics the abilities of a human arm. Through the use of user-centric design concepts and state-of-the-art research, the MPL is enabling people who have lost limbs to reclaim their independence and reach new heights of functionality in their daily lives. Number 7. Mind-controlled bionic leg. Mind-controlled bionic legs provide a revolutionary way to restore mobility and freedom of movement for people who have lost a lower limb. Innovative prosthetic legs that react to the user's neurological commands directly have been created by companies such as USR and the Center for Intelligent Mechatronics at Vanderbilt University. These bionic legs provide users the ability to move fluidly and precisely while walking, climbing stairs, and navigating a variety of terrains by sensing even the smallest muscle contractions and reacting accordingly. Number 6. The NeuroRex exoskeleton. An innovative method of assistive robotics for those with spinal cord injury is the NeuroRex exoskeleton. This mind-controlled exoskeleton, created by Rex Bionics, allows users to stand, walk, and even climb stairs with little effort. For people with severe mobility disabilities, the NeuroRex exoskeleton restores mobility and independence by using neural impulses from the user's brain to create a seamless integration between mind and machine. Number 5. Neuralink Neural Interface. Elon Musk's Neuralink project, though still in its infancy, has great potential for mind-controlled prosthetics in the future. The goal of Neuralink is to create high-bandwidth communication between the human brain and external devices by implanting ultrafine electrodes directly into the brain. Neuralink's neural interface technology has been initially developed for neurological problems and cognitive enhancement, but it has the potential to enable more sophisticated mind-controlled prostheses with unparalleled functionality and accuracy in the future. Number 4. DARPA's Haptics Program. With its Haptics Program, the Defense Advanced Research Projects Agency DARPA continues its tradition of leading the way in technical innovation. The goal of this large-scale project is to create sophisticated prosthetic limbs that can provide users with a tactile and proprioceptive experience. DARPA hopes to develop mind-controlled prostheses that not only imitate the movements of natural limbs, but also give users tactile input and sensory awareness, improving their total experience of embodiment and control. This will be accomplished by fusing neural interfaces with artificial skin and tactile sensors. Number 3. Advanced Upper Limb Prosthetics. The goal of the U.S. Department of Veterans Affairs funded Advanced Upper Limb Prosthetics (ALP) initiative is to transform the upper limb prosthetics industry by utilizing advanced brain interfaces and machine learning algorithms. ALP prostheses can learn and adapt over time by utilizing neural signals from the user's brain, maximizing their functionality and performance to meet each user's unique requirements. For those with upper limb loss or impairment, this customized approach to prosthetic design has the potential to greatly enhance quality of life. Number 2. Myoelectric Prosthetic Hand. For many years, myoelectric prosthetic hands have been a cornerstone in the prosthetics industry. However, with the latest developments in neural interface technology, these devices are becoming even more versatile and effective. Myoelectric prosthetic hands detect and amplify electrical signals produced by the user's muscles, allowing for remarkably precise and elegant control. These prostheses are getting more responsive and intuitive with the incorporation of machine learning algorithms and cutting-edge sensor technologies, making it easier for users to do challenging tasks. Number 1. Mind-driven robotic exoskeletons. Apart from prosthetic limbs, exoskeletons with robotic mind controls have great potential to improve movement and independence in people with mobility limitations. These exoskeletons can assist with powered walking and other activities by deciphering neural signals from the user's brain. This lessens the physical strain on users and makes it easier and more efficient for them to perform daily duties. Leading companies in the development of thought-controlled exoskeletons, such as Rewalk Robotics and Bionics, provide a new standard of mobility support for those with spinal cord injuries and other mobility limitations. For those who have lost or are severely impaired in one or both limbs, The development of futuristic mind-controlled prostheses is a unique convergence of neuroscience, robotics, and engineering, and it offers new hope and possibilities. These innovative technologies are changing people's lives all over the world by restoring mobility, freedom, and dignity from exoskeletons to brain-controlled arms. Future advancements in the field of mind-controlled prostheses have limitless promise as long as research and development in this area continue. Share this video with your loved ones. Goodbye.